Alrighty, CNT120, Chapter 3, we're continuing on our section on IPv4 addressing. Again, just remember, here's a couple special numbers. There's your loopback and there's your PIPA addressing. Make sure you remember those. Here is our example of loopback. I did this earlier, but I just kind of put this here as a reminder. That lets us know if we ping 127.0.0.1 successfully, that lets us know our NIC is functioning, TCP/IP is installed and functioning, our IP addressing is functioning, if you will. So our NIC, it's kind of like a little self-check. Our NIC and network connection should be functioning correctly. Remember, a PIPA, automatically privately assigned IP address. If my computer is set for dynamic addressing, but there's an issue, some sort of connectivity issue between my computer and the DHCP server, my computer after bit self-assigns a 169.254. So if we in IT are working on a client computer, a customer computer, and we're seeing a 169.254, that is usually a really good sign, really good indicator there's a connectivity issue that we need to resolve, because we don't usually use these numbers for anything. They're self-assigned when we don't have a good connection to, especially our DHCP server. So here, the client asks for address from the server. It tries to discover it, and the server, for whatever reason, the connection, the server down, whatever, it doesn't get an address, so it self-assigns that 169.254. And here we are. We're set for dynamic, and there's an issue, so I get a 169.254. That's what we're seeing there. There are some private addresses, special IPv4 addresses that are private, set aside for private use. Well, first thing we want to mention is all these Class ABC licensed addresses are available for use in the internet. These are called public IP addresses. But a company or even your house can use private addressing. And that allows us to use an addressing scheme that we haven't applied for in our network, in our house, in our place of business. And this is perfectly okay to use. These numbers are set aside for that purpose. Your 10 network, your 172.16, and your 192.168. These numbers are set aside that we're allowed to use internally in our network. They're not going to get routed outside, but we can use them internally for our networks, and we don't even need special permission to do so. There's the full breakout of those. Well, what happens is, we'll talk about this in a little bit, network address translation will translate these private addresses inside to the public IP address that your ISP is giving you. So these are allowed to be used inside. They're not going to get routed out because our router will translate these into the public IP addresses that we're allocated to use. All right, IP addressing in CIDR, CIDR, classless interdomain routing notation, pronounced CIDR notation. This is a shorthand way of identifying our network and host portion of address. So our default subnet mask of 255.0.0.0 for like a Class A, there's actually 8 bits here representing the network portion. So the shorthand way to write this is literally just a /8, meaning there's 8 bits here identifying the network, and if there's any subnetting in this network. Class B, 255.255.0.0, there are 16 bits here for our network and subnet portion of the address, network portion of the address. So these 16 bits I can write as a /16. So again, this right here, this subnet mask here, this means the same thing. And lastly, our Class C address, 255.255.255.0, that default subnet mask indicating the first 3 octets are network, while there's actually 24 bits there. So I can represent that same thing with a /24. 24 bits representing the network portion of this address. So we'll go back to our earlier examples that we had. If we have a Class A network, 110.50, so forth, and the default subnet mask is 255.0.0.0, that can be written as a /8. So if I see a network and I see 255.224.0.0 or /11, because those mean the same thing, we would know that subnetting has occurred. Now, there were 8 bits here, and this, when I convert, is this number right here, which is 3 bits in binary. So 8 plus the 3, it gives you your /11. That /11 means this in decimal, means this in binary if I convert those first 2 octets to binary. If I have a Class B address, 150.39, I'm expecting network host. I'm expecting 255.255.0.0 or /16 because there are 16 bits here. If I see that 150 number with a 255.255.240.0 subnet mask or /20, that lets me know some subnetting has occurred. Now the /20 comes from, 8 bits here, 8 bits here, so there's 16. And then if I take this 240 and write it out in binary, this is what I get. So I have 8, 8, 16, 17, 18, 19, 20. There's 20 bits in that subnet mask. So that would let us know that some subnetting has occurred. And if I have a Class C network, 210, 83, so forth, I'm expecting 255.255.255.0. That would be my default subnet mask, or /24, because there's 24 bits there for that subnet mask. But if I happen to see a 255.255.255.192, that lets me know some subnetting occurred. And if I convert that, well, here's the 8 bits, 8 bits, 8 bits, and then there's the 24, 25, 26. That's the 192 in this octet. There's those 2 additional bits, so there's my /26. That would let me know some subnetting has occurred. So that's how that CIDR notation works. It's just how many bits are in the subnet mask, including any subnet portions that are there. That is your CIDR notation. Well, as we move on to DHCP, Dynamic Host Configuration Protocol, remember we can do static addressing like we said before, and I would do that on things like printers and servers. I would use the following, and I would need to carefully code all these numbers in. One number off, and it may not work, or one number off, and it might not let me apply it because it's like, no, that's not a usable number. Okay. So for hosts in a network, we typically do dynamic setting. So on my NIC, I say obtain IP address automatically. And that allows that node to, when it boots up, ask the network, ask a DHCP server, can you give me all the IP addressing information I need to work on this network? And it does it for it. So what actually happens then is the server is set up to hand out IP addresses from a range of numbers. So on your DHCP server, you're usually defining a scope or a pool. You'll hear those names get used kind of interchangeably. Some of the equipment we use, we define a DHCP pool. Sometimes on the server, you define a DHCP scope. So the first thing you define is usually a range of numbers or a subnet of IP addresses that the server is going to hand out. Sometimes you define the starting and ending. Sometimes you just do the starting and it hands the rest out. You'll usually define the lease time. How long can that be borrowed for? If you have shifts of workers that are using computers or something like that, you might have a short lease time that, after their shift is over, that's released for another shift to use. Or you might have it be, open for a week, so it's not constantly asking for new IPs. You're also going to include a gateway address, typically the router that's going to get you out of the network or out to the internet. That is part of that, to say, hey, give this computer the gateway address so they know how to get out. And it also pass along the address of a DHCP server. As like, hey, if you have a question on a name, send it to this DNS server, the DNS server. Send it to this DNS server and it'll resolve that name into an IP address for you. And on a server, it tends to look like so. You're plugging this information in of handing that out. And again, this has to be plugged in carefully, or you're handing out bad information and your nodes aren't going to get anywhere. They're not going to get outside your network. If I have an entity on the network, maybe like a printer, you could actually code it into the server to say, whenever this printer comes on, just hand this printer this IP every time. And that'd be like a reservation. You reserve that number. That way you don't actually have to code it into the printer. You just get the MAC address from the printer, put it in the server, and say, hey, whenever this MAC address shows up, give it this IP address. That way it'll be the same all the time. Sometimes that's easier to do than going to the actual device itself and hard coding it in. So you can actually set aside some reservations, DHCP reservation or MAC reservation or IP reservation on your server, that it always gets that IP address. And again, this would be some settings you would do on the server. Now, reserved IP address is not the same as static. That reserved IP IP address is it is reserved for that device. So every time it boots up, it'll ask for the address, but it's always going to get the same address. Static IP address, we said before, it doesn't request anything. That's just what it uses. And as long as it's right for the network, it'll use it. On a server, sometimes you also define an exclusion range. Numbers that the server's not going to hand out. Sometimes they're called a reserve pool. Sometimes they're called an excluded range, again, depending on the server that you're working on. But this would be a range of numbers that do not get handed out by the DHCP server. In our 125 class, when we do DHCP configuration on our routers, we typically hold back a bunch of numbers at the beginning of the subnet so they don't get handed out. And those numbers can get used for things like printers, servers, access points, those kind of things in your network. And next section, they talk about address translation. So remember before we mentioned about private addressing. Private addressing inside your network at home or inside your business, you can use that private addressing, and when it hits the router is going to translate that into a public IP address that can be used outside, one that came from your ISP. I'll pick on like Comcast or Verizon for your house. Comcast or Verizon has allocated your house an IP. That can get translated into the private scheme that you have inside your network. And there's different forms of translation. Port address translation is commonly what gets used at home. So port address translation, your private scheme inside, when it hits the router, that's going to get converted to the outside IP that comes from, again, a place like Comcast, Verizon. And what it does is it keeps these separate by using port numbers. These are all going to get translated to this IP address outside, and it says, okay, I think we have here, 8,000. Port 8,000 would map to this computer. 8,001 gets mapped to this one. 8,002 gets mapped to this one, and so forth. So now it has a table of any traffic coming back. If it's destined for port 8,000, it'll know to translate it into this IP and send it to this computer. And that is how it can convert your private scheme inside to the public IP address that's outside and keep them separate using different TCP port numbers. Really, 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 really neat, really, really sneaky, if you will. There's two variations of NAT, source network address translation and destination network address translation. Your source network address translation, your small home network typically uses this. You have a single IP address outside. The gateway assigns a public IP address to a host each time it makes a request to access the internet. So here we have, again, our nodes inside. It's going to get converted to an IP address outside. So these private entities inside are going to be using this IP address outside. And it's either going to use those ports, like we said, to sort them out, or every time it requests, it just uses that IP. That'd be your source network address translation. The destination network translation is going to be going the other way. So hosts outside can get to things like a web server, email server inside. So now, coming this way, this needs a translation into a specific IP address on the inside. So there has to be a table that says this, an IP address coming from the outside is going to get mapped to this IP address inside for the web server or the email server. That's your destination network address translation. Alrighty, when we come back, we will move on to IP version 6 addresses.